Our last video today is going to be talking about rotating around the unit circle. So we're going to be focusing on the different directions, counterclockwise and clockwise. As you noticed in the last type of example, if you're going in the negative direction, that's going to be clockwise. So, you think clockwise, when the hands of the clock move this way, you think that's the normal way, but in the unit circle, remember the degrees go counterclockwise. So this is actually negative. So we would subtract if it's clockwise. With counterclockwise, that would be going the opposite way the hands of a clock would move, and that's when the degrees count up. So we'd want to add if we're rotating around. So let's look at a few different examples. We're going to use the unit circle. This is where you're going to want to have your unit circle handy, because at this point you probably haven't memorized it yet. So we can look on it for reference for looking at some numbers. Now, what we want to do is use the unit circle to find the location. That's the coordinate. And angle measure of each rotation. And the angle measure should be either given in degree or radian or both, depending on what you're given. So to start with, we're beginning at -1, 0. So if you refer to a unit circle, -1, 0 is left 1 and not up or down. So that point should be right here. And let's just draw a little circle here for reference. So -1, 0 is right there. That's your starting point. Now we want to rotate clockwise at 60 degrees. So we first have to think about what degree do we start at -1, 0. And this would be 0, 90, 180, 270, and 360. So we're starting at 180 degrees. So I want to think of this in terms of degrees, not coordinates. Our starting point happens to be at 180 degrees on the unit circle. I want to go clockwise 60 degrees. So clockwise, remember, is negative, and we want to subtract. So we want to subtract 60 degrees from 180 degrees. And that's going to give you 120 degrees. So that's the angle measure. So the angle measure also, you have to get the coordinate as well from that. So 120 degrees is between 90 and 180. That's in quadrant 2. And 120, the way I think about it is 120, is it closer to 90 or closer to 180, or is it halfway in between? And if you look at the number 120, it should be closer to 90. So it would be at this point right here. So that angle, 120 degrees, leads you to a coordinate of, now in the unit circle you can check, but it should be -1/2, comma, and when one coordinate's 1/2, then the other one's square root of 3/2. Since the y value is in the positive direction, it'll be positive square root of 3/2. So -120, and that's at -1/2 because it's in quadrant 2, and the x values are negative in quadrant 2, comma, the square root of 3/2. So there's your angle, there's your location, your coordinate. And I guess that's your answer to the question. We could get the radian measure of that too if we were asked for it. We would just multiply by pi over 180. And 120 over 180 is 12 out of 18, which is 2/3. So that's 2 pi over 3. So sometimes we're asked for the radian measure, and that would be another way to represent that angle as well. And we can check that also with our unit circle. Ask that you kind of just keep one handy right now since we don't have it memorized. And you can see right there at 120 degrees, the coordinate is -1/2 square root of 3/2, and that radian is 2 pi over 3. So that does match up. All right, example B, example 3, letter B, continue. In this case, we want to begin at the coordinate negative square root of 2/2, comma, square root of 2/2. So think about a unit circle. Where is that coordinate? The x value is negative, the y value is positive, which means it's going to be in quadrant 2. And when it's the same coordinate, square root of 2/2, that's halfway in between. So we're starting at that angle. So remember, this is 0, 90, 180, 270, 360. That coordinate right here is halfway between 90 and 180, so it's going to be 90 plus 45, so it should be 135 degrees. And we can verify that on here. 135 degrees, negative square root of 2 over 2, comma square root of 2 over 2. So you want to start with that degree. We want to go counterclockwise. Remember, counterclockwise is positive, so we want to add from that 135, 165 degrees. I know 35 plus 65 is 100, so that should be 300 degrees. We can check that in the calculator. 135 plus 165 should be 300. And so I have my degree, and I can get my radian too if I wanted to, 300 times pi over 180. That one's a little harder to reduce, but you can use your calculator if you need to. Remember that if you can use a calculator and you want to, you would do that by going to Desmos, or you can use your graphing calculator, and you would simply do, what is it? 300 divided by 180, and hit the fraction bar, and that'll reduce to 5/3. So you can check that with by hand if you want, but that's going to be 5 pi over 3. So before we look at the unit circle, I want you to think about where 300 is, because this is really important to get a visual of where 300 is. 300 is going to be closer to 270 than it is 360. So it's going to be right here. And that coordinate is in quadrant 4. So the x value is positive and the y value is negative. And the x value in this case will be half, 1/2. And the y value will be this negative, the square root of 3 over 2. Okay, when it's closer to this axis here, the x value is 1/2 when it's closer to 270. So positive 1/2, negative square root of 3 over 2. Let's double check that. So at 300 degrees, we're at 1/2 comma negative square root of 3 over 2. Awesome. And then we got 5 pi over 3. So 300 degrees, 1/2 comma negative square root of 3 over 2 is your location. And it's also 5 pi over 3 as a radian. So remember, these are both angles. This is a degree, that's a radian. Okay, let's look at letter C. We're going to begin at 0, -1. So let me draw out a little unit circle again, a little quadrant. 0, -1 is going to be left. It's not going left or right. It's going to go down. So that's going to be there. And that should be at 270 degrees. So 270 degrees is your starting point. We want to go clockwise. Remember, clockwise is subtract. But we can't subtract a radian from a degree, so we'd have to convert one or the other. So that's really up to you. If you wanna go to your unit circle and say that is 3 pi over 2, or convert that to a radian, that's fine. But the problem is that we still got to convert those fractions, all right? It's 3 pi over 2 and 4 pi over 3 do not have common denominators. So usually what I do in this problem is I'll convert this to a degree and deal with that first. And we're going to do 4 pi over 3. We're going to multiply that 4 pi over 3 times 180 over pi. Remember, if we're converting to a degree, we want to cancel those pi's out. So that's 4 times 180 divided by 3. Or you can do 180 divided by 3, which is 60, and then multiply that by 4. 6 times 4 is 24. So 60 times 4 will be 240 degrees. 240 degrees. And let's verify that. 240 degrees is 4 pi over 3. So let's do it that way. 270 degrees minus, now that we have 240, we're going to bring that down here. And that's going to be 30 degrees. There's your angle. But we want it in a radian in this case since it started at 4 pi over 3. So if we think about where 30 degrees is, it's going to be right over here. If you remember our 3 radians in here, we had 30 degrees, 45, 60, and this was pi over 2, pi over 3, pi over 4, and this was pi over 6. And we can verify that here. 30 divided by 180, 30 pi over 180. 3 goes into 18 6 times, so this is going to be pi over 6. Now, do you remember what that coordinate is? They're both positive. The x value should be square root of 3 over 2, comma, 1/2. And just like at 60 degrees, it was flipped, so 1/2, comma, square root of 3 over 2. So 30 degrees, pi over 6, and square root of 3 over 2, 1/2 is your coordinate. So that's your location. So that's your final degree. As a radian, it's pi over 6. As a coordinate, it's square root of 3 over 2, comma, 1/2. All right, we got one last one for you to try. Okay, so we want to begin at 0, 1. We want to go counterclockwise 7 pi. So where is 0, 1? If you haven't done any of these yet on your own, I really would encourage you to pause the video and make an effort to try this on your own. All right, spend a few minutes trying to go through it and make sense of it. Have your unit circle available to check. When you've finished, unpause it and you can hear my explanation. 0, 1 is going to be up here. 0, 1 is at 90 degrees. So we're going to start at 90 degrees. We want to go counterclockwise. So counterclockwise is adding. So we want to add 7 pi. That's a radian, that's a degree. Convert that to a degree. So we'll multiply by 180 and divide by pi. There is no number to divide here. So what we're going to do is we're going to cancel the pi's out and just do 7 times 180. So 7 times 180 is, you know what? I don't know that. So $1,260. That's a pretty big number. So we're going to do 90 plus 1,260 degrees. Let's see, 1,260 plus 100 is 1,360. So knock down 10, it should be 1,350 degrees. That's nowhere even close to being on the unit circle. So we're going to have to bring that down into a number between 0 and 360 before I can identify the quadrant. So think back on the last example where we're doing coterminal angles. We had to subtract 360 several times on some of these to get down to a number between 0 and 360. So let's start here and let's look at the problem. Try to get them side by side here so we can. There we go. All right, so we have 1,350. I'll start by minusing 360, and you get 990. We're going to minus another 360, and you get 630. We're going to minus another 360, and you get 270. All right, so that's our degree that we're going to end up with. 270 degrees, and I can convert that to a radian if I want. 270 divided by 180 is 1.5 as a fraction. That is 3/2, so that's going to be 3 pi over 2. Remember, we're putting a pi after the division, so it's going to be 3 pi over 2. So let's see where that is. On the unit circle, 270 degrees is right there. So if you think about it, we went counterclockwise. 7 pi, that's 3.5 circles, right? 1, 2, 3.5 circles, because one full circle is 2 pi. So that's where that comes from. And so we're going to end up right there at 270. So it's 270 degrees. That radian is 3 pi over 2. Now that coordinate, well, that's right here at one of the corners. So that's actually going to be at that's going to be at 0, -1. And let's verify all of that on the unit circle. And those three things line up. 3 pi over 2, 270, 0, -1. So you can get this unit circle while you're practicing. I'll have a link shared with you that you can just have this unit circle, but it's up here. It's in the website called Embedded Math, and it's all filled out for you. At some point, since we're out of school right now, you don't technically have to memorize it because you can just refer to it. But once you get back into a school in a class, you'll need to know it. So here are the three things that you want to have for your final answer for that. All right. Well, you have a wonderful day. I hope the assignment is friendly after being able to watch this, and you have a great rest of the afternoon.